One thing you may want to do with frame 2 is to select the row at a particular index. You can use the number of the index or the label of the index. There are two functions to use depending on whether you want to use the number of the index or the label of the index. To select a row at index 2, you will use the iLog. Observe that the index of the row is provided within square brackets. Also note that the row with the label 3 is at index 2. Let's execute this statement. You will use lock to select a row by label. This statement will select the row with the label 2. You can select multiple rows with iLog like this. Try to select multiple rows by label with lock. A more common and important operation is to select columns. This statement will select the state column from the data frame, frame 2. If you like, you can use the dot operator to return a column, but if you have an attribute or function with the same name as the column in the environment, you may run into problems. For example, you can return the state column if you execute the statement frame2.state, but you will run into problems if instead of state you want the count column. You are sure to return the count column if you use the square bracket and provide the column name within single or double quote. You can also return multiple columns with the double square bracket. This statement will return both the state and count columns of frame 2 data frame. Remember that all the value in the rating column of the frame 2 data frame is NaN. This statement will assign the value 4.2 to all the elements of the rating column in frame 2 data frame. Let's print frame 2. Although 4.2 is a scalar, the scalar is broadcasted throughout all the elements of the rating column. Alternatively, you can assign a list to the rating column of the data frame. This statement will assign this list to the rating column of the data frame. Let's print frame 2. You can also assign a series to a column of a data frame. Because of data alignment, which is a property of series, the output will depend on the index of the data frame and the series. For example, Observe that the rows of frame 2 are indexed with labels 1, 2, 3, and 4, and the series rate are naturally indexed from 0 to 3. There is no data alignment between the two. Let's try to assign the series rate to the rating column of frame 2. Let's print frame 2. The reason why there is no data alignment between the two is that the data frame is indexed with labels while the series is indexed with numbers from 0 to 3. Let's print frame. I will now assign the rate series to the rating column of frame. Let's print frame. The assignment is successful because there is data alignment between the rate series and the frame data frame. Both are indexed from 0 to 3. Can you guess what this statement will return? This statement will return a boolean with true for every element of the category column that matches the string SE. This statement will assign the boolean returned here to the column SE of the data frame, frame 2. Let's print frame 2. You can delete a column in the data frame with the del keyword. This statement will delete the SE column of frame 2. Let's print frame 2 again. That column is gone. Like NumPy array, you can transpose a data frame. Let's transpose the data frame, frame 2. The axes of the data frame have been swapped such that the columns are now rows and the rows are now columns. What if you want to find out if a string is a column of a data frame? You will use the in keyword. This statement will do just that. This statement will return true if emo is a column of the data frame, frame 2. False is returned. This statement will return true if 3 is an index of the data frame, frame 2. True is returned.